Hi there, you should be on page 10 of your Algebra 1 Quarter 3 notebook. In this video, we're going to focus on putting all of our exponent rules together. So just before we even do that, if you can turn to page 12, and I just wanted to kind of look at this law of exponent summary. How do you know when you're done simplifying expressions with exponents? Four things you need to make sure. First thing, coefficients have to be simplified. So if I have this 8 and this 6, that is not simplified. Why? Because 8 and 6 are both divisible by 2. So this should be 4/3, or you're not fully simplified. All like terms, or those same variables, have to be combined. I can't have bases of x in the numerator and the denominator. I can't have like an x to the 5th up here in the numerator. Everything has to be combined or it is not fully simplified. I can use the rule that suits me best to simplify them, but I've got to combine them. All exponents have to be positive. I cannot have a negative exponent in the denominator or in the numerator, and I cannot have zero exponents. I should never be leaving z to the power of 0. This should be 1. And since 1 times any number is itself, this expression should be x to the 8th y squared. Alrighty, so let's go back over to page 10, and we are going to take a peek at number 1. And the first thing in number 1 I'm going to notice is that it's some fraction multiplication. And I want to realize that with fractions, I multiply straight across, right? But the commutative property, well, let's just kind of multiply straight across and just write it like it would be. I'd get 2x squared y, 9xy squared. That's multiplication in between all of these, right? Over 3 times x times y to the 4th. Now, the commutative property of multiplication is going to let me move this around. So I'm going to move my two coefficients together. I've got 2 times 9. I'm going to move my exponents with bases, same bases. I've got x squared times x. I've got a y and a y squared. And down here in the denominator, I have 3 times x times y to the 4th. So I don't have any distributing. That's one thing I always look for, but I do have the same bases here in the numerator that I can combine. So, and of course I can do 2 times 9. 2 times 9 is 18. Then I have x and x here. What is 2 plus 1? That's x to the 3rd, or x cubed. And y to the 1 plus y squared is also y cubed. Over 3xy to the 4th. Now, I do need to simplify my coefficients, right? So 18 divided by 3, I know is 6. But I have x to the power of 1 here and x to the power of 3. I'm going to use my quotient rule and see that this is x, 3 is bigger, to the 3 minus 1, and that is x squared. And here I've got y to the power of 3, y to the power of 4. 4 is bigger, so I'm going to have this be in the denominator y to the 4 minus 3, or y to the power of 1, which is simply y. So this multiplication and then expression is simplified to 6x squared over y. Now I'm going to look at number 6. Okay, I don't have any distributing, but I do have negative exponents and I have some coefficients that definitely can be simplified. So I've got this 25 and 35. And I know that they are both divisible by 5. 25 divided by 5 is 5. And 35 divided by 5 is 7. 5 divided by 5 is not a whole number, so I cannot simplify that further. Okay, do I have any of the same base in the numerator? No. Do I have the same base in the denominator? No. So I can't combine in my first step. So I'm going to go on and look for my negative exponents and move that. So I'm going to b to the 5th stays, but a to the negative 3 moves down right next to a to the 5th. This b to the 5th stays as well. C squared stays, but c to the 9th now moves to the numerator. Okay, it looks like after doing that, I do have some same bases in the numerator that I can add. So I have 5b to the 5th. 2 plus 9 is 11, so I've got C to the 11th, over 7, a to the 3 plus 5, which is a to the 8th, b to the 5th. I still have b to the 5th and b to the 5th. So I still have b in the numerator and the denominator. This is 5 over b, it's the same number. B to the 5 minus 5, c to the 11th, 7, a to the 8th. 5 minus 5 equals 0, right? And b to the 0 equals 1. This equals 1. So I am going to take that out, and I end up with 5c to the 11th over 7a to the 8th. So that expression is now simplified. Anyway, here we go, moving on to page number 8. And I do have some distributing to do. This is going to be that power of a quotient here. I've got to distribute 4 into my numerator. So I have x to the 4th over 4, 2 to the 4th, y, 2 times 4 to the 8th, times, distributing the 2, 2 squared, x squared, y to the 3 times 2, which is y to the 6, over 3 squared. This is fraction multiplication, so remember I'm going to multiply straight across. While I'm doing that, I'm going to kind of rearrange my factors in the numerator and denominator so I have my coefficients together, my x's together, and my y's together. So I'm going to put my coefficient 2 squared first, and I'm going to put x to the 4th times x squared times y to the 6th. In my denominator, I'm going to put 2 to the 4th times 3 squared times y to the 8th. All right, now I can do some evaluating. What I can see here is that I can combine my x's, and I could also do a little simplifying of my numerator, my coefficients, but I'm not actually going to do that yet. I'm just going to combine that and get 2 squared because I have the 2 as the common base. X to the 4 plus 2, which is x to the 6, y to the 6, over 2 to the 4th times 3 squared times y to the 8th. And this is why I didn't evaluate these yet, because I'm going to look here at the same base with exponents. 4 is bigger, so I'm going to bring that down to the denominator. So now that goes away. X to the 6 will remain. But if I look here, I've got y's in common as well. So this is going to be 2 to the 4 minus 2. X to the 6 stays, so does 3 squared. And I'm going to, 8 is bigger, so it's going to be y to the 8 minus 6. So now I'm going to look here and I get x to the 6 in the numerator all by itself, 2 to the 4 minus 2, which is 2 squared, times 3 squared, times y to the 8 minus 6, which is y squared. All right, so I'm going to evaluate my exponents with their coefficients now. Bases, 2 squared is 4, 3 squared is 9, times y squared, and 4 times 9 is 36. So I always find it very exciting to look. You start with that, and it boils all the way down to x to the 6th power over 36y squared. Alrighty, we're going to look at number 9 and 10, see if we can get these done before I have my 15-minute limit. I am going to do some distributing first in number 9, and I'm going to have 5x to the negative 3y squared over x to the 5th y to the negative 1 times 2 to the negative 2, x to the negative 2, and y, 3 times negative 2 to the negative 6 times xy. Now I am going to combine these, right? And at the same time, I am going to move my x's together and my y's together. So I have 5 times 2 to the negative 2 times x to the negative 3 times x to the negative 2 times y squared times y to the negative 6, all over x to the 5th, x to the 1st, y to the negative 1, y. Let's see what this looks like when I combine my common bases. I've got these is the same, these are the same, and these are the same. All right, I have 5 times 2 to the negative 2. I have not moved my negatives yet. I have negative 3 plus negative 2, which is x to the negative 5th, times 2 plus negative 6, y to the negative 4th, over x to the 6th. And now I have y to the negative 1 plus 1, which is y to the 0. I know that equals 1. Alrighty, now I'm going to move my negative exponents. 5 will remain in the numerator, but 2 squared moves down, 2 to the negative 2 moves down. X to the 6th remains, x to the 5th moves down. That's 1, y to the 4th moves down. So, combining here and evaluating, I end up with 5 over 4, 2 squared is 4, 6 plus 5, x to the 11th, y to the 4th. Again, just look at all of this, and it all simplifies to that. Number 10, I see clear distributing. I'm going to distribute in this, and then distribute here. So I have negative 2 squared. I'm going to make sure my negative 2 is in parentheses. X times 4 times 2, x to the 8th, negative 5 times 2, y to the negative 10th, and z to 6 times 2, z to the 12th, times 3 to the negative 2, x to the negative 3 times negative 2, x to the 6, y to the negative 6 times negative 2, y to the 12th, and z to the 7 times negative 2, y to the negative 14th. Let's now put all the things together. I am going to do negative 2 squared, x to the 8th. I'm going to move x to the 6th, y to the negative 10th, y to the negative 14th, z to the 12th, z to the negative 14th. Going to combine my bases. Negative 2 squared. Oops, I forgot. Sorry, I forgot this. 3 to the negative 2 times 3 to the negative 2. This is 8 plus 6, which is x to the 14th. This is negative 10 plus negative 14. That's y to the 24th. This is 12 minus 4 plus minus 14. That is z to the negative 2. Alrighty, let's move my negative exponents. I have negative 2 squared over 3 squared, x to the 14th, y to the 24th, z squared. And then I have got, okay, let's evaluate. Negative 2 squared is 4, x to the 14th, y to the 24th, 3 squared is 9, z squared. And so this expression evaluates to that. That's it for this video. Thank you.